Hi all, thanks for joining. My name is Alejandra Bovides and I will be talking to you today about understanding establishment thresholds of mangrove pioneer species in North Sumatra and its implications for restoration. Mangroves are tropical and subtropical coastal forests that live in the edge between land and sea, between fresh water and salt water also. Because of this, they host a rich biodiversity and provide a wealth of ecosystem services which, despite we recognize their value, more than 30% of mangrove cover has been lost worldwide, historically speaking. This, over the last decades, has prompted intense restoration efforts, which unfortunately, more often than not, fail, with a success rate estimated in no more than 20%. The main identified cause of this failure is related to most cases inadequate topography, inadequate hydrology, or a bad choice of a species for a given restoration site. But most importantly, we have a gap of knowledge on establishment thresholds, which is a key element to having success in these restoration programs. Let's remember that mangroves exist within highly dynamic sedimentary environments. They are subject to regular tidal flooding, currents, erosion, and sediment accretion. The establishment of mangroves in a bare mudflat is initiated when disturbance-free periods allow diaspores to germinate and securely anchor to the sediments. After the initial establishment, seedlings interact with the physical environment, reducing hydrodynamic forcing and trapping sediments, eventually increasing elevation and promoting the development of secondary species, after which ecological processes dominate the ecosystem landscape. We are focusing this study in the pioneer phase of the biogeomorphic succession, using the mangrove species Avicennia alba, which is considered to be a pioneer. We deployed them in mesocolumns experiments where we were able to simulate different lengths of windows of opportunity, these periods without disturbance, and tidal flooding. In contrasting salinity conditions, salinity creates this physiological drought in seedlings that reduces growth rates, so can also influence the rate of establishment. Our results show that regardless of window of opportunity treatment, salinity is a main driver in the probability or the success of establishment, with a delay in establishment of about 1 week between low and high salinity, and a maximum probability of establishment within this period of time, half the amount of what would be observed in low salinity conditions. In high salinity treatments, what we found is that windows of opportunity are detrimental for a successful establishment. For Avicennia alba, windows of opportunity of 3 days had the highest establishment. Within smaller windows of opportunity, propagules don't have enough time to produce a strong root system, and early floodings might wash seedlings off or just dislodge them. Whereas in windows of opportunity that are longer than 3 days, extended exposure to sun can increase dehydration. If we look now at the average root length and root frequency for all window of opportunity treatments used, we can see that all treatments at windows of opportunity smaller than 3 days have the shortest roots for both salinity treatments. This is most likely related to dislodging events, which might inhibit root development and additionally expose roots to sunburn. If root tips burn, they are unable to develop any further. They are aborted, so to speak. We can now say then that optimal disturbance-free periods for Avicennia alba is in some place around 3 and 5 days. Let's see now how that relates to natural establishment in the field. This histogram is showing the cumulative frequency of windows of opportunity events of 1, 3, and 5 days along an annual average daily inundation duration. This means that, for example, a site that is flooded in average 10 hours per day in any given day of the year is located at lower elevations than a site with a 6-hour daily inundation average. Windows of opportunity of 3 days or more occurred within sites that have inundation daily averages smaller than 9 hours, and their highest frequency occurred between the months of January and March, which synchronizes with the regional availability of propagules. This means that the phenology of the Visenia alba is well harmonized or synchronized with windows of opportunity events during the year. Understanding species-specific establishment thresholds will help build up on restoration models that can consider natural succession, including hydrology and optimal windows of opportunity for a given species. Avicennia alba is a pioneer species that is sun-demanding and has a fast growth development. But different species have different establishment thresholds, different salinity tolerance or flooding tolerances. So further research is needed in order to have more successful management and restoration strategies.